Well, hey there, kiddos. Today we're going to continue multiplying polynomials together. The only difference today is we're going to have a binomial times a binomial or a binomial times a trinomial. It's not going to be just distributive property like yesterday. We're going to start just like we did yesterday, though, and we're going to do a problem involving algebra tiles. And so you're going to have to draw your little your offset T here again so that we can line stuff up. And so now I have, instead of having one thing here, I've got two. I've got a binomial. I have x minus 1. So I'm going to have to put my x over here, just like I did yesterday, but I'm also going to have to put a minus 1. And so I'm going to have the negative. And so I'm going to have my negative over here as my minus 1. Then I'm going to have to do x plus 3 over here. So I have my x, and then I have 3 of these. And so when I multiply these together, here's what's going to happen. The first thing I'm going to do is x times x, which you should know by now makes x squared. Then I have to do x times my 3 negatives. I have to do them one at a time, and so I have x times a negative, or sorry, those are not negative, those are positive. X times positive 1 makes an x, and so I'm going to get this, and this is going to happen 3 times. And so I have my 3 x's, and then down here on the bottom, when I do negative 1 times x, it's going to make a negative x, and then a negative 1 times these 3 positive makes 3 negatives. And so here's what you end up with if you're doing algebra tiles. And now we're going to combine things together so I can simplify it to write it as a final answer. And we're going to draw it as a picture. I changed my mind. We're not going to draw it as a picture. We're going to write it out just algebraically so that you can see what it looks like algebraically. And then we're going to talk about how to solve this algebraically instead of having to draw the pictures. Well, I have my 1x squared here. And then I have 3 x's and then a negative x. Well, this negative x takes out that positive x, so I have 2 x's left. And then I have 3 negative 1s, so that becomes minus 3. And that's what this is simplified. Now, if I want to solve this algebraically, which is the other half of your table there, it's very similar to doing the distributive property, only we're going to do something called the double distributive property because we're going to distribute twice. We're going to do it double. It's going to make this little double rainbow. So we're going to start with our x that's in the first binomial, and I'm going to distribute this x to everything over here. So I'm going to have to do x times x, which makes x squared. And then I'm going to do x times 3, which makes 3x, which if you see in my picture, I've got my x squared and my 3x here. That's that first set of distribution. Then I'm going to distribute again right here, and I'm going to do negative 1 times x, which makes negative x. And then I'm going to do negative 1 times 3, which makes minus 3. And then what should happen, if you are doing this correctly, these two terms in the middle should be combinable. They should be like terms. I should be able to put them together. And so I end up with x squared. 3x minus x makes 2x minus 3. And you should notice that this is the same answer as this. One I used pictures to get. The second one I just did it algebraically doing double distributive property. And so they're the same thing. I distributed this x to everything up here and got my x squared plus 3x. And then I distributed the negative 1 to everything and I got the negative x minus 3. It's the same stuff that I have here, just one is pictures, one is not. So let's try a few more problems. There are 2 ways actually to do these algebraically. One is the double distributive property like I just showed you, and then one is something called the box. It's the box method, and everybody feels a different way about this. Some people really, really love double distribution, and some people really, really love the box. It just sort of depends on what kind of learner you are and how you see things. So we're going to do the box method with this second problem so that you can see it. I do not care how you choose to do them. As long as you use one of the methods I'm about to show you to solve these problems, it really doesn't matter. So here's how the box method works. You're going to have to draw a box. I have 1, 2, 3, 4 total terms, so I need a box that has 4 little boxes inside. It needs to be a 2 by 2 box because I have a binomial and a binomial. I'm going to line these up outside my box. So I have x minus 3 is the first binomial, and x minus 5 is the second binomial. And then you just break it up one little piece at a time, and we're just going to multiply. Sort of like a Punnett square that you did in biology for genetics. Well, x times x makes x squared, so that's what goes here. Then x times negative 5 becomes negative 5x. Do not forget to put the x on that number. It will mess you up if you don't. Then I come down here. Negative 3 times x makes negative 3x here. And then negative 3 times negative 5 makes a positive 15. And just like when I did double distribution a minute ago, these two boxes right here that are diagonal from each other should be like terms, and I should be able to combine them. So I end up with x squared, negative 3x, and negative 5x make negative 8x plus 15. So that's the box method way of solving this problem. The other way is double distribution, and I'll alternate between the two as we practice some more problems. So look at number 3. Let's do double distributive property. I'm going to do 3x times x, which makes 3x squared. And then I'm going to do 3x times 4, which makes 12x. And then down here I have negative 2 times x, which makes negative 2x. And then negative 2 times 4 makes negative 8. These I can put together, so I end up with 3x squared plus 10x, because 12 minus 2 is 10, minus 8. So I end up with a trinomial as my answer, and that's what it looks like. So now number 4 looks a little different. You just see one binomial. I have 2 minus y, but the whole thing is squared. And if you will remember, to square something means to multiply it times itself. So rewrite it out in expanded form so that you can see it. So now you can see what it looks like. Let's draw our box, and let's multiply this one using the box method. 2 by 2 box, because I have 2 binomials. So I have 2 minus y and 2 minus y. Then multiply. 2 times 2 is 4. 2 times negative y is negative 2y. Negative y times 2 is negative 2y. And negative y makes positive y squared. Then we write them out. 4, I can combine these, minus 4y, because negative 2 and negative 2, that's what that makes, plus y squared. So there's your answer. Do not try to just do this with this problem. Do not try to distribute that exponent and make this equal 2 to the second minus y to the second. This is not what it equals. You have to expand it out and multiply the two binomials together. So you should end up with a trinomial. So number 5, double distributive property again. 2x times x is 2x squared. 2x times negative y becomes negative 2xy. I just put my two variables together. I can't combine their exponents because they're not like bases, so they just become xy. 3y times x is the same thing as 3xy. And then 3y times negative y is negative 3y squared. So again, put my middle terms together. So I have 2x squared. Negative 2 plus 3 becomes 1xy minus 3y squared. And that's your final answer. You have no like terms to combine. You're done. So now look at this last one, number 6 here. This one, you have a binomial times a trinomial, and you can use either method here. You can do double distributive property, which is what I'm going to do, but if you choose to do the box, when you do the box for this one, it has to be a 2 by 3 box because you have a binomial and a trinomial. So you have your 3x minus 5 here, and you have your 2x squared, 4x minus 3 here. And so you will multiply that way. Just your box has to match the number of terms that you have that are being multiplied together. And so that's how you get your box. But I'm going to double distribute because that's what I prefer. So 3x times 2x squared. Well, 3 times 2 makes 6. X times x squared is x to the third, because remember there's a little invisible 1 there. And then 3x times 4x makes 12x squared. And 3x times negative 3 makes negative 9x. So there's the first part. Now we're going to do the second part. I'm going to change colors again just so you can see. Negative 5 times 2x squared becomes negative 10x squared. Negative 5 times 4x becomes negative 20x. And then negative 5 times negative 3 makes positive 15. Now let's look for like terms. I have 6x to the third and nothing to combine it with, so 6x to the third just comes down. Then I have a 12x squared minus 10x squared. Well, 12 minus 10 makes 2, so I have plus 2x squared. Then I have negative 9x minus 20x, and so negative 9 minus 20 makes negative 29x, and then my plus 15. So this time I ended up with a 4-term polynomial that is to the 3rd degree because my highest exponent is a 3. Instead of a trinomial as my answer. It's just because I multiplied more things together. So now let's extend this to some word problems. So we have a square tabletop that has side lengths that are 4x minus 6 units. We want a polynomial to represent the area. Well, I have a square, and squares, all the sides are the same. That's a pretty good square. And when I find area, I do length times width, or side times side. So I'm going to do 4x minus 6 times 4x minus 6. And I'm just going to double distribute. So 4x times 4x, that's 16x squared. And then 4x times negative 6 makes negative 24x. Then again, that makes another negative 24x. And negative 6 and negative 6 makes a positive 36. Combine these, so the area of your tabletop is 16x squared minus 48x plus 36. And I just multiplied my two things together and went about it that way. So now they want us to find the volume. I'm given a prism. They say find the measure of the volume of the prism in terms of x. In terms of x means there better be an x in your answer. You can't just, the x has to be there. And they want your answer in simplest terms. Well, if you remember, volume is length times width times height when you're dealing with the prism. And so I'm going to take this 2 pieces at a time. I'm going to do my length and my width first. X times x plus 3. So I'm going to do x times x plus 3, and let's get those out of the way. Well, x times x becomes x squared, and x times 3 becomes 3x. So now I have to multiply this times my other part, which is 2x squared minus 3. So now I double distribute just like I was doing before. X squared times 2x squared becomes 2x to the 4th. So I have to add those exponents. X squared times negative 3 becomes negative 3x squared. Then 3x times 2x squared becomes 6x to the 3rd. And then 3x times negative 3 becomes minus 9x. Now you don't have any like terms, but standard form, standard notation for writing a polynomial, you always put them in decreasing degree by exponent. So it should go 4, 3, 2, 1 in terms of the exponent. So the 2x to the 4th comes first because that's the biggest. The 6x to the 3rd should come next because it's the next biggest exponent. Then the negative 3x squared, and then the negative 9x. These are the same thing. This is just standard notation. It's how you will see it written more often than not. But so that's how we do those problems. Length times width times height, just multiply all 3 sides 2 at a time. Take the length and the width, then multiply by the height, or however you want to do it, because order doesn't matter. Double distributive property or the box, whichever you feel the most comfortable with, and we will practice this tomorrow.